So let's move into multiplying and dividing. And you can read these rules um, and this approach, and then pause it, read, and then we'll continue. We've already started to see how to multiply things together. If numbers are on the outside, we multiply them together. And if we had numbers on the inside, we multiply them together. We're going to use that same approach. Numbers on the outside work together, numbers on the inside work together. And then we always have to simplify our results. When it comes to dividing, that's where we have to be careful that we don't leave any radicals in the denominator. So you can look at a few examples of multiplying these radicals. Both the 3 and the 6 are underneath. So the answer 18 is under the radical sign. And then we simplify it. In the second example, the 4 and the 3 are on the outside. So we multiply those and get 12 on the outside. 3 times 6 gives us 18 on the inside. And of course, we simplify that. So just to show you, this is 12. And the square root of 18 is 3 square root 2 from the previous question. And that's how we multiplied those together to get 36. So I used the answer from the previous question. And in our last one, of course, negative 1 times 2 for negative 2, 12 times 6 for 72 under the radical sign. And then we broke down the 72 and then brought that negative 2 down. So again, we're building on the first half of this review lesson. So that's why I'm not showing all of that work. Once we get to this line, it's exactly the same as the first half of this discussion. Simplify the square root of 72, bring down the negative 2, and then multiply the numbers on the outside. If the numbers were bigger, we might choose to simplify them first. For example, in the first one, instead of multiplying 18 times 54 and getting 972, and then doing one really big factor tree, I simplified each of them, then multiplied them together. But then I had to check, because when I got my 12, I'm having issues with my laptop here, sorry. Once I got that 12, I have to check, does that answer simplify again? So I might have to simplify more than once. In the second example, I'm only going to have to simplify once, but the number is much bigger, which means there's much more room for mistake. I get the same answer. It is personal preference. So let's look at a few. And there's a couple in here with variables. We're not going to worry about that right now. That's not going to be a focus for us at the moment, but we can always come back to that if needed. So for example, in the first one, I might multiply these together. And again, I'm just going to make the screen a little bit bigger, give us a little more room to work with. So in number 1, I can multiply that together and get square root 200. Well, that's 2 times 100. And now I could keep going. 2 times 50, or 4 times 25, and 25 is 5 times 5. Or, because this goes back to the beginning of the lesson. Or what I could do is, I know 100 is 10 times 10. Remember, our whole goal is to find pairs. So if I know that that's a pair, I don't have to go all the way to the prime factors. I could stop there. And I get 10 square root 2. We could have gone all the way to the prime factors. So you might want to try it that way. But ultimately, what we're looking for is pairs, 2 of a kind. And I found them right there, 2 10s. So I'm going to use it. In number 3, outside with outside. So that's negative 3. Inside with inside gives me a 60. But now I have to check, can I simplify a 60? So I'm going to ignore that negative 3 for just a minute, and I'm going to work right here. 2 times 30, 2 times 15, 3 times 5. I like to start with my lowest prime number because then they're already lined up for me. I have a pair of 2s, so that's a 2 on the outside, and my 3 and my 5 stay home. So I have 2 square root 15. Now, I got to make sure I don't forget. I'm going to bring that negative 3. I'm going to bring that negative 3 down. And my final answer is negative 6 square root 15. So if you want, try 2 and number 4, number 2 and number 4. Forget the x's. We don't even have to worry about them right now. So for our purposes, if you want to try these, don't even worry about the variables for right now. We can always come back to those later if we need to. Okay. And here's a few more. In fact, well, there they are. That's actually the same numbers. I by mistake, I added the second slide and I dropped the variables, but you can do those. So pause the video and try number 2 and number 4, and then come right back and you can watch me do it. But definitely pause the video here and try it. All right, so let's see how you did. I get square root of 24, and I like to break it down 2 and 6, 2 and 12, 2 and 6, 2 and 3. There's my pair. So 2 square root 6. And for number 4, I think if I multiply these together, let's see, I'm going to get a bigger number, 600, but it's really not that bad. So I'm going to multiply and get negative 10, and then 50 times 12 is 600. And I'm going to work on that 600. That's a 6 times 100, which is a 2 and a 3. And the 100 is a 10 and a 10. So it looks like I have my pair. So 10 square root 6. I'm going to bring down the negative 10 for negative 100 square root 6. Okay, so hopefully you did pretty well on those. So now we get to dividing, and dividing is always a little bit of a challenge. We're not allowed to have a radical in the denominator, and that's really where we present the challenge. So in dividing, we can do a couple different things. We want to separate the numerator and the denominator. So in our first example, you can see that that's already done for us. We simplify the square root of 8, 2 square root 2, and we simplify the denominator. Square root of 9 is just a 3. In the second example, remember, we're not allowed to have fractions in the radical sign. So the one thing we're allowed to do is just split the radical sign, top and bottom. And we end up with the same exact problem. So one technique is, if we have a fraction inside the radical, is just split the radical, put it on top and put it on bottom. And then we'll figure out what we have to do. So remember, whenever we have fractions, we always want to reduce fractions. In this example, I split the radical, top and bottom. I simplified the top. Then I simplified the denominator. And thing to notice here is that we always reduce fractions. So this goes back to numbers on the outside work together, numbers on the inside work together. On the outside, I have a 2 over 2. Well, 2 over 2 is 1. So they cancel out, and we're left with square root 3. If we take the original problem, we can split it. Now, since both the 12 and the 4 are under the radical, remember my little rule. When the numbers on the outside work together, so that's why the 2 and the 2 reduced. Numbers on the inside work together. So both of these, the 12 and the 4, are inside the radical. That means we can just reduce them. 12 over 4 is 3, but the answer stays in the radical. And we get the same exact answer. It's just how you envision or how you step through the problem. Numbers on the outside work together, numbers on the inside work together. The only way to get out of the radical sign is by pairs or the buddy system. Otherwise, you have to stay in. Okay, so now we have to talk about rationalizing the denominator. And I'm going to step us through a couple of these. So let me make this a little bit bigger. Let's look at number 1. 5 over 3, I can't reduce it. The first thing I'm going to do is split it up. Square root 5, square root 3. And now we have a problem. We're not allowed to leave that radical in the denominator. So this radical right here is the problem. The way we're going to get rid of it, it's called rationalizing the denominator. We're going to multiply by it. Because if we take a square root of 3 and square it, it's going to cancel. Squaring a square root cancels out. So square root, if we square a square root, it cancels. We get that 3 right back. Because, and this is really important to understand, what are we really doing? We're multiplying that 3 times 3 under the radical, giving us a square root of 9. And what's the square root of 9? It's simply a 3. So that's what we're going to do in this question. We're going to rationalize the denominator. We're going to multiply by the radical. Only the radical. In the numerator, we get square root 15. In the denominator, we get a 3. And I just showed you why. This is really the square root of 9, and the square root of 9 is 3. So right now we have square root of 15 over 3. And that's actually our final answer. Remember, square root 15, regular 3. We cannot reduce those. Numbers on the outside work together. Numbers on the inside work together. Well, here we have a 15 on the inside and a 3 on the outside. We cannot mix those together. So we cannot divide the 15 by 3. So let's take a look at number 2. Square root 8, square root 5. The problem is we are not allowed to have that radical in the denominator. So what are we going to do? We're going to rationalize it. So this is, again, rationalizing the denominator, meaning we multiply by the radical. Now we have a square root 40 in the numerator and a plain old 5 in the bottom, in the denominator, because this is a square root 25, which is just a 5. At that point, we would simplify the square root 40 if we can and see what we end up with. So I'm just going to work on the side here, a square root 40. That's 2 and 20, 2 and 10, 2 and 5. So I do have a pair. So it looks like I get 2 square root 10 over 5. That's a 10. Let me fix that. That's a square root 10. And that is our answer. 2 over 5 does not reduce. And the 10 is on the inside, the 5 is on the outside. Can't reduce those. Let's do one more. And number 3, very similar to number 2, I can split it up and then work on the numerator, work on the denominator. If we think about something from before, 24 over 10 can simplify. I could divide by 2. So if I wanted to, I can do that and get the numbers smaller first. It's an option. That's really square root 12 over square root 5. It just makes the numbers smaller if I reduce first. We're going to rationalize the denominator. And then we're going to simplify the 60. So if we can simplify the square root of 60, we're going to try to do that. We're going to get a 2 square root 15 over 5. And again, the square root 15 and the 5 cannot cancel. One is in the house, one is out of the house. They don't play together. And you can try number 4. Get a little practice with that. So here we have a few more questions that we can try here. We have some pretty interesting ones. We can see what's going on here. Let's take a look at number 5 here. So number 5, we have a radical in the denominator. What are we going to do? Rationalize. So, sorry about that. So we're going to rationalize that, multiply top and bottom by the radical. So 4 square root 80 over just 10. Because this is the square root of 100, which is 10. Now check it out. We've got a 4 and a 10 on the outside. Well, 4 over 10, that reduces. So we can reduce that to a 2 over 5. And we're going to bring the 80 with it. But remember, we have to simplify the square root of 80. So over on the side, and I'm going to come out onto the right side here, square root of 80. That's 240, 220, 210, 5. I have pairs. So that's a 2 and a 2 on the outside, 5. So 4 square root 5. So I'm just going to write this. It used to say 2 times square root of 80. Now it's going to say 2 times 4 square root 5. And now on the outside, I have a 2 and a 4. So that's 8 square root 5 over 5. And again, the square root 5 and the regular 5 cannot cancel. So that is our answer. So that question included everything we've done in this whole review. We had to simplify a square root of 80. We had a number on the outside, 2. We had to rationalize the denominator, the square root 10. And we had to reduce the fraction, 4 over 10. So there was a lot going on in that question. We had to deal with all of it. Let's do one more together. So let's take a look at number 7. Now, 15 times 50 is going to give me a pretty big number, right? 750 that I have to simplify. We can do that. That's not a problem. If I want, I can reduce it first. I can simplify the 50 first. So again, I'm just showing you different ways to use all the same skills. And it doesn't matter what order you do it, long as you do it all the way. So we can do this almost in any order. So watch what we're going to do here. I'm going to work on that 50. Square root of 50 is 2 times 25, which is 5 times 5, which is a 5 square root 2. So I'm going to rewrite this. Negative 15 square root 15 over 5 square root 2. Just rewriting it. I changed the way the square root 50 looks. And now, just look for a rule that's broken and fix it. So the first thing I did was I made the numbers a little smaller. Hey, we're not allowed to have radicals in the denominator. So let's fix that. I'll rationalize. And again, we can do things almost in any order. So I'm going to decide radicals are not allowed in the bottom. I'm going to fix that. So now I have negative 15 square root 30 over 5 times 2. So I have negative 15 square root 30 over 10. But what I just noticed was that 15 over 10 can be simplified. So what do you get when you simplify a negative 15 over 10? You get negative 3 over 2, and that square root 30 comes along. And finally, I should always double check, can a 30 be simplified? So I would do my factor tree, and in this case, the answer is no. So this is my final answer. Okay. And that is a brief review of the radicals work, simplifying radicals work from Algebra 1 that we are going to need in geometry. Okay, so that is a quick review, and we will talk more as needed and get everybody situated.